At Simio, we're in the business of showing you the future. Our intelligent technology gives you unprecedented insight into complex systems to identify and solve today's inefficiencies and tomorrow's challenges. The Simio solution provides a low-risk opportunity to drive transformational change. Our true digital twin models capture all the constraints, business rules, and decision logic that define the operation of your system. When powered by your data, easily evaluate unlimited scenarios and deliver optimized solutions. No matter what industry you're in, eliminate your greatest operational process and scheduling challenges with a Simio digital twin. See your future success, Simio.
Perfect. Welcome, everyone, to the Simio Solution Series 2024. Start off. Today's session is going to be on batching logic. My name is Dan Vasilini. I'm the VPS Global Sales over here at Simio. Doing most of the presenting is going to be Drew Rose. Drew is one of our solution engineers. You will see a QR code at the bottom of this screen as well as at the bottom of another screen. I would ask if you're interested, if you'd scan that QR code at some point during this presentation or after this presentation. We're always looking for feedback on our solution series, both from what you've seen in this session as well as future sessions you might like to see. Any type of feedback is welcomed, so please feel free to scan that QR code and give us some feedback. Before we get started, some housekeeping items. Please be aware that today's session is being recorded for replay purposes. If you'd like to watch this session in the future or rewatch this session, or if you'd like to recommend it to a coworker or a friend, it will be on the Simio webpage. We usually have the sessions up in about 24 to 48 hours after we hold the session, so you can assume by the end of the day tomorrow it should be live on the Simio webpage. To find it on the Simio webpage, simply go to simio.com. There's a resources tab across the top. Under that resources tab, you will see the Simio Solution Series dropdown. In that Simio Solution Series dropdown is going to be this session as well as any session we've done in the past. So we've got dozens of sessions out there now that we've been doing since 2022, I believe it was. So lots of sessions out there, lots of recordings, lots of different topics. We try not to repeat ourselves, and we try to attach or attack topics that people are interested in. So please feel free to visit there and take a look. Also, be aware, today's session, participants, when you enter, you will be on mute. If you'd like to ask a question during today's session, you should see a good webinar dashboard somewhere on your screen. On my screen, it's on the top right-hand side. In that dashboard is a chat area and a questions area. What I'd ask is you just drop down the question and type your question in there. Once your question comes in, we will address it. I try to ask the questions if they're relevant to the topic that the presenter is currently talking on and can be answered pretty quickly. I'll try to ask it at that point in time, or if it's more generic in nature, I will wait till the end and ask it at the end. Session today is scheduled for 60 minutes long. Drew has probably about 45 minutes or so to present, so we always try to leave a little time at the end for questions, but as always, people will ask questions during the session, which we encourage. If those questions do come in or when they do come in, it might take our session a little beyond that 45-minute of pre-planned time. As far as future is concerned, if you attended our last session, I had mentioned or I had stated that we would not be doing in August. We would skip August and do September, October, November, and wrap for 2024. Well, we changed that. We had some feedback, and even though we do know a lot of the country and world is on vacation in July and August, we don't want to miss a full month, so we did add a topic for August. So highlighted there is what we're going to be doing for August 18th, September 12th, October 17th, and November 13th. Those are on the Simio webpage. You can sign up for any of those at any point in time. And as always, we'll be alerting with some emails that go out prior to the sessions a couple weeks prior. So you can sign up at that point in time. But I know a lot of people like to sign up for future sessions, and then they don't have to worry about waiting for an email or anything to come out. So you can always sign up for those future sessions right now or when this session ends. If you are watching this session on recording, you can find it on the Simio webpage, and you can record it right there, almost kind of where you came into this recording. Lastly, like I said, I want to thank everyone for attending today. That QR code is on this screen. After Drew is finished presenting today, I'll probably bring our names back up again, because if questions don't get answered that we attempt to answer, or if we don't have time, or if we run out of time, I'll bring our names and email addresses back up so you can email us directly. And on that email page will also be the QR code. But if you can scan it now or scan it prior to me talking right now, that'd be great. So that said, I'm going to turn things over to Drew. Thanks again for attending, and we look forward to questions when they come in. Drew, the stage is yours.
Very good. Thank you, Dan. Let me get the screen up and firing. All right.
Confirming.
Confirming screen is sharing.
Yep, you're sharing, and you're sharing just the slide, so good to go.
Very good. All right. Good morning, good afternoon, good evening. As Dan Vasilani mentioned, my name is Drew Rose. I'm a solutions engineer here at Simio. I'm excited to talk to you all today about batching logic. So let's get started. So I want to start off with a little bit of just kind of workshopping what is batching logic all about. So depending on your system and your industry that you may work with, batching logic may be something that you've worked with extensively, or it may be something that hasn't really worked with in much capacity. So hopefully today, when you walk away from this session, you can think about where batching logic may apply in your system, because ultimately, batching behavior is everywhere. We see that in all different systems, all different industries. There are mechanics of a model that could call for batching fundamentals. So like some common examples that you would maybe come to mind are putting boxes on a pallet. And we have a batch of boxes that go to the same pallet and are shipped out as one single order. Or similarly, if we're in a manufacturing assembly line and we have all these different subcomponents, we could have those be all batched to a final assembly. So those are some classic examples, but what I'm going to cover today is maybe a different way to look at what we view as a batch, or within the confines of Simio, what we think about batching logic. So I've got a couple models we'll get into today that cover this topic, and maybe a different lens that you probably wouldn't think of in your day-to-day. And really, when we think about using batching logic, some of the main benefits of doing so is that there's going to be a lot of logic that is consolidated with our object library in our certain objects. So our combiner and separator will make good use of. And really, I think within batching, instead of having to go down the route of process logic or some customization, letting these objects work for you is going to minimize the customization, which I know for myself, the more I can do out of the box, that makes life easier. So that's going to be a main benefit. And then we can also think about when to batch. So maybe there's some parallels you can draw from what we talk about today, but really there's some nuance to when in your model may be the right time to batch. So it's important to understand your modeling goals and inputs and your visualization. So maybe you want to have entities that are batch members, and you want to visualize entities moving through the system, as opposed to maybe putting a state variable that could mimic a batch of entities. There's some nuance to that, and we have a few different approaches as well that'll cover that. So really, when we want to have entities behave similarly to one another and have them move through a system, that's often where batching is the foundation of. So lots to get to. And a little bit more on today's specific agenda. We'll go through the fundamentals, showing with some applications of the combiners and separators, as well as some of the properties that maybe could often be some trip-up points, perhaps, on using the combiner. So we'll talk about matching members together, or batch members, how we use match members and parents, and the distinguishing factors between the two. We'll talk about some release batch early triggers and how those could play a part in your combining process. And then potentially a data-driven approach to how you want to model. So something that could be more robust in a data-driven model, how we can use those to our advantage. As well as talking about hierarchical batching. So maybe there's a few tiers of batching that exist in your model. We'll talk about that. And then some unique extensions of batch behavior beyond the norm. So lots to get to. And with that, we'll start to get into the application. So I want to give a little user story. So before being at Simio, I used to live in Raleigh, North Carolina, and fresh out of college, Drew had quickly discovered the fast food restaurant known as Cookout in North Carolina. So today we're going to cover something that's near and dear to my heart, and that being cookout trays at my fast food joint. So during this time, right out of college, still learning how to cook and all that, I would often go through this service and this restaurant, and I would get myself a tray. And we'll talk about what this looks like when we get into Simio. So we'll talk about how we would set up a data structure to have these trays be modeled and going through a fast food restaurant. So I would go and I would get myself an entree. I would get myself a couple of sides, and then I would choose a beverage. Generally, I was a shake guy, but we'll touch on the options that exist. So you can use this as the foundation and where we're going to start from. So now we'll convert over to Simio, and we'll get into the model itself. And confirming from the Simio side that now my screen moved into Simio.
Good to go, Drew.
Excellent. All right, so want to start here. We'll kind of cover a few different aspects, but we'll get into the model and how we can start to use batching logic to capture this behavior. So in this given industry and in this given restaurant, we'll touch on how we convert that data that I just showed into action in this model. So I've set up some data tables, and I've really covered what I viewed as my go-tos when I was down in the Carolinas. So these are my four main options. I had a set of, these are when customers would come in, I could choose from any one of four entrees. So I have my four entrees, as well as I have my three some different side items, as well as a few different drink items. So I've taken those and I've identified those as objects in my given model. And then I also have all those combinations mixed out. So if I was to get combo one, I'm going to have a big double burger with cheese bites and a huge tea. So that's kind of we're building out a structure, and we'll go back to this in a moment's time. But really taking that entree list and et cetera, putting that into the Simio model. And when we run this, and we'll start here, and then we'll start to peel back the onion. But this is just going to show a day's operations at the local cookout. So we're going to have cars come in, and there's going to be two modes. So customers can either be drive-through customers, as we see here, or there is also the option at these cookout restaurants where you can park, and then they have a walk-up window where you go to, and you can be a walk-up customer. So two different modes. And during this given day, we're running the model from 10 a.m. till 10 p.m. And as orders are introduced and customers are introduced into the system, I just have a sample representative rate table defining the arrival. So customers arrive with a given rate table, and this could take any number of forms. As you know, in your models, your inputs can be a number of different ways, but hour by hour, we're just going to show some different arrival trends. So maybe during the lunch hour, we experience a higher number of arrivals. And similarly, during the dinner hours, we also experience more customer traffic. So that's how customers arrive in, and with a percentage, they're going to be either drive-through or walk-up. So when we start this model and customers arrive in, depending which route they take, if they were to go down the walk-up path, they would enter the parking lot. And really, that's kind of the first piece of where we would start to unpack this batching logic. So if a customer comes in and they decide to go down the path of going to one of these parking spots, that's where we can start to figure out how we distinguish a car to a customer. So at this separator, and I've introduced each parking spot as a separator, and we'll talk on the approach there. So I have on each of my cars, as they arrive, I've set up a state variable on them that defines, and I'll go to my car. I have a state that is defining the number of passengers. So kind of talking to that initial point in the slides on the granularity in which you want your model to suggest. I'm going to first start out with a state to define some of this unbatching behavior. So as customers arrive, they're going to be introduced, and I am setting up a number of passengers, and I just have kind of a simple triangular statement that we're going to have anywhere from 1 to 5 passengers in a car at any time. So as customers come in, they're going to randomly sample from this, and this is defining how many passengers are in that car. So as that happens, they'll get a number of passengers assigned to them, and then they will ultimately find a parking spot. And once they find a parking spot, that's where we first do our first unbatching. So at this separator object, and this is again one of our standard library objects, we are defining the separation mode. In this case, I am making copies of the default because similarly to the number of passenger state variable, I also have a few other identifiers like the car ID, and we'll touch on when this is relevant. And I want my copies to have some of the defined state variables that I previously set. So by making copies, I'm copying over characteristics of the parent so that those carry out to my batch members. So as they're introduced, I will make copies dependent on that state variable that I've defined. So I will have anywhere from 1 to 5 passengers get created. And in this case, my parent is a car entity, but I want to ultimately create my customer entity. So that they can go and route accordingly because I have different behaviors for the different entity types. So as they arrive and are separated, we'll have 2 different distinguishments for how things route. And I'm just putting on the nodes just for visibility's sake. So my parent, in this case, is the car. The car will ultimately go back to a combiner, and we'll touch on how that combiner plays a part. But my members, in this case, I've defined that they are going to go as a customer specifically to the walk-up order station. So they will arrive here, and they will ultimately find a route to get to the walk-up window. So distinguishing 2 different paths for the different behaviors. If we run this a little bit, and I will go to, I'll just put a breakpoint on my input here. We'll let this run. And once we find, there we go. So we had a car. Let me find that car. It had on it, we've defined the little Jurassic Park car. So we had 3 passengers that were defined. And then so we ultimately made 3 copies of the parent. The parent being, they all have the characteristics of this car. So car 369 has a relationship with these batch members. So as they arrive, these are going to go, and they will go to their walk-up window. So our customers have memory of which car they came from. So they all have this car ID assigned to them. And now they're going to go do their ordering. So 3 customers arrive from the same car, and now they're going to go and create a given order. So stopping the model, we'll touch on the next separator. So this is the first piece of the hierarchy, and kind of the greater structure of the model is the first relationship is customers to car. So that's a 3-to-1 relationship of splitting out customers per car. Now each customer, the next layer of this hierarchy is each customer is going to have a unique order to them. So not every customer is going to want the same combination. And you'll see in some of these combos, they can be probably rather aggressive for the lunch hour to have cheese bites and milkshakes all before noon. I know that's probably not a day-to-day, but ultimately, when they go to the separator, they're going to go and for 20 to 35 seconds, again, a rather arbitrary processing time, they're going to go and do their order. So maybe they're looking at the menu, doing what they need to do, and they will conclude their process. But when they conclude, they will again make a copy, referencing again the properties and states that exist on the parent entity, but we will ultimately generate an order entity. And that order entity, we'll see where that routes to next, has some other attributes to that. So when we make our entity, that will take place, and then we will go and send the parent. Again, they will continue to wait in the walk-up window queue, but the order entity now is going to go to item creation, so another layer of splitting. And on that process, we've also distinguished after processing. One other nuance to this batching is that because we have a data structure around how we're generating our combinations, I wanted to dip into process logic a little bit to create these unique entities for a given batch. So we had the order go in. So let's assume we again run here. They came here and they ran their order, and let's say they came up with a given combination. So we're going to put a breakpoint here, and we're going to look at trace to see what process logic is taking place. And I'll remove this breakpoint. So we generated we've selected a combination that we're going to choose from. So we created an order off of that, and then we're going to first find in our bit of process logic, we're going to look through what combination did we find. So we're going to search and find the combination that we set. And there was a previous set row that with a mix, I could have selected any of these 48 rows. So I selected a combination. I'm going to see what items are in that given combo. So I've selected, and let's see, we've selected rows 61 through 63 of our table of combinations. So if I look down here, rows 61 through 63, that suggests that I had selected order 21. So on order 21, I got my set of quesadillas, onion rings, and milkshake, typical lunch. And with those, now I'm going to have this get sent back to the kitchen that these items are going to need to be created. So we're then going to go and create each of these food items to be sent back to our back-end kitchen. So I'm going to create a quesadilla item, an entity. I'm going to designate in my table of items which type is this. And then correspondingly, I also have a data table defining the tasks that it takes to run this job. So quesadillas, and if you're familiar with sequence tables, that takes on this approach, and there's other solution series that cover this topic at more length. But I'm designating that a walk-up customer who ordered quesadillas, we need to get these quesadillas to go to the grill, and then they need to go to the tray prep in order to be fulfilled. So I'm designating on my sequence as well what tasks need to take place, and I'm sending this order into the kitchen. So that's taking place for the quesadillas, and then my onion rings, and then my milkshake. So from one order entity, that is now generating 3 different items that are to follow suit. So that's taken place. And then when I go back, now and just for busyness sake, I've just separated the kitchen just to have it in a different space. But that's going to get sent back to our kitchen, and that's going to need to be fulfilled. So in this area, we've designated the different stations in order to how we're going to process these given meals. So I have in my kitchen, my fryer, my grill, my burner in the event that I have chili, a milkshake, and my drink machine. So my different, in this case, these are servers, but this is helping to create my given orders and fulfilling when I have a order for a given item that's calling for the grill, they'll go to the grill, they will be cooked and be sent back to our station. So when they go and we produce our items, those ultimately get sent back to the kitchen. And now we have our item, and our order entity in this case is represented by this tray. So this tray is the parent. And now it's going to be looking for those different members that were created. So it's going to be based on this combination. We're going to create those items off of that. So we've created our quesadillas, our onion rings, and our milkshake, and that's going to be shown on the queue. Those are generated, and now we've set the sequence that they are going to go route through, and they're going to be wait to be fulfilled. So when that takes place, and now I'll then pause here. The next step is that we then, once these operations have taken place and they've routed and been cooked and processed, we're going to need to rebatch the members back to the parents, and that's when we go and use one of these tables. And in this case, we now introduce the combiner. So at this combiner, and this is, I'll just introduce the default one real quick. We can have many different ways of batching. So on this combiner, we can say, what is the quantity with which we want to batch? Do we want to match members, match parents? And we'll touch on this at more length. But in this case, in our data-driven approaches, we want this combiner to be able to handle and fulfill all different possible order combinations. And that's in that case where this combiner could handle X number of given combinations. I want to map this to a data table to define these relationships to say which members should be matched with which parents. So in this case, I've taken this and I've mapped it to a given table that I've set up for batching. So in this table, we're defining the order entity. So again, kind of that hierarchy that exists. Which combination do we select? Those items that we've generated are going to look to see which given combo should they go back and find. So when we go to order combo 21, when those 3 items get processed, they will route to, and I'll turn on my queues, they will route to this member queue. So they will route to my drive-through tray prep, and the members will come in from the given kitchen, and the parents will set up here, and we will look to see, and we will look to batch based on those setups. So I've run this for a little while, and I've got to turn off the breakpoints here. Our tray will arrive. So our tray is waiting for those entities to come through. And then as we run this, now we have another order waiting in the queue. We see our items are being cooked for a period of time. We're going to have our items start to come in. So as we start to fulfill orders and we do our processing, we're going to start to batch based on the given types of assemblies that we're after. So all this is going to occur, and for this given order, we got our milkshake fulfilled. So what someone in the kitchen fulfilled the milkshake. Then we're going to wait for the onion rings, and then lastly, we're going to get the quesadillas. And once those arrive, and we see our quesadillas are now arriving, they will batch, and then that will ultimately, and I have a connector being used to map it back to my main table. That's going to route back to this area, and we're going to fulfill that given order. So that's going to match back with, now that the order itself has been batched, it's going to go back to the window that it came from, and it's going to be batched accordingly. So you see that in this case, we have this customer. This is a single passenger that was getting this given order. They got their tray of items, and I just visualized the queue kind of on here just to show the items that were mapped. And I paired the customer in the order back to the parent that it came from. So in the context of using the walk-up window, I'll remove this breakpoint. If we see items go back here, we'll start to see our entities go through. So, and then at this point, once they go to this walk-up window and they have finished their batching, or I guess prior to that, at this given combiner, we're also going to pair back. This is where we would first introduce the concept of matching members and parents. So another point at the beginning of why it is important to make copies is at the beginning, we've also established a counter element, or we have what we use as a counter that is our order ID. So this is just an integer state variable that every single order that is generated in the model, we're going to make an assignment that matches this order ID with this given customer. So as we are going and making that copy, that's also something that's going on in the back, is one of our processes is making an assignment to say, this customer generated order 50. And order 50 is what's getting sent back to the kitchen to be fulfilled. But now we need to make sure that when these orders are being fulfilled in the kitchen, that they get paired back with the proper parent. So in this given case, this is where we would start to think about matching members and parents. So as we go and generate a member that is an order combination, so combination 21, that has an identifier, and that parent also takes on that identifier. And that's when we want to make sure that the right member matches up with the right parent. We don't want to hand the customer the wrong order. So that's what this rule is designating, that the customer that is seeking this given order must have the right order arrive at the right time. So as all the orders come back in, they're checking to see, is this order ID matching with this parent ID? If so, it's a match, the order will be fulfilled. And upon conclusion, that's then kind of taking all this hierarchy in its totality. We go back, and that original parking spot that we've been at for a period of time, I'll remove this breakpoint. Let it run. So we're going to have these parents that are going to sit now at this combiner. So this car ultimately is sitting in the parent input buffer of its combiner. So it is waiting at this parking spot for, again, that same rule criteria to be adhered to. So the car itself has an ID, and this is just a Simio specific modeling ID that is designating which particular customers should match back with which particular car. Because in the context of reality, you wouldn't want your customers to route to the wrong car. They need to know which car they're going to go to. So we're going to wait for that, the batch quantity being the state, the number of passengers that we designated in this case. That being, we need to wait for a batch quantity of 3 to be met. And when we do so, we need to make sure that each customer that arrives to this car is in the proper location. So once we have all 3 customers arrive, and I will just make that occur here. Once they all get back to their location, I'll put a breakpoint. These are customers going through the drive-through. We see that our members are starting to route back to the car. So customer 1 got their given meal, the second customer got their meal, and now we have the third customer that's coming back with their meal. So we got all 3 fulfilled. And now we have a car that has the proper 3 customers with it, and the queue is just showing them all in one location. But we have kind of this hierarchy that exists. 1 parent being the car, with 3 batch members, the customers. And then the second tier is the customer is now the parent, with its batch members being the items that came to them. And then the third tier is the order itself and the individual items. So kind of showing an example of hierarchical batching, the different echelons that could exist in your given model. So like in a warehousing sense, you could have parts to boxes, boxes to pallets, pallets to trucks. That's kind of the same type of ecosystem that could exist in any given industry. So just a unique application of that. So as they run through, they'll go, and I'll turn off this breakpoint, but let's say we just want to run this model and the drive-through follows a very similar structure with all the different fulfillment methods and things to that end. We'll run this for the duration of the model, and then we'll just look at some simple KPIs. I'll turn off my trace. But ultimately, what this can generate is just something of a simple output table that shows all the different behaviors that occurred. So all the different orders that took place, what car were they a part of? So that car, we see car number 3 had 3 different customers in it, 3 different orders, 3 different combos, and they went to the drive-through. So that you can really take a look at, if you're looking at analysis from this model, you can see all the different behaviors that took place. But let's say ultimately, if we wanted to think about a little more of process efficiency to this model, and we have the different combinations that exist, all of which require different equipment, grills, fryers, etc. Maybe we want to see, based on the behaviors that come in, what is the utilization of each area and how many of these types of orders are we getting. So tracking all the while the number of orders that were for each given food item, we're taking that. And if we look at a different way, we want to see by equipment area, which is going to be the most heavily utilized. So of our 5 stations back in our kitchen, we see that the grill itself is being most heavily utilized because it has 4 items that it needs to be that need to use the grill, whereas the fryer has 3 items, and then the milkshake machine and chili is a little more niche, just to one particular item. So based on that, we can also see that the utilization aligns with the demand. So our fryer and our grill are the most heavily utilized objects, and the utilization is also a byproduct of just some processing time. So the grill is anywhere from 1 to 2 minutes to grill an item. The fryer could be 1 to 3 minutes. So that could lead to some of the different utilization rates. But maybe we see this in mind, and we see our historical demand, and that's where we could set up the foundation for experimentation. So with all of that in mind, we have varying levels of capacity, and we're trying to determine, should we add a unit of capacity? And that's where you could set up controls, and then we could set up experimentation off of this, and we could identify the optimal capacity of each of our kitchen stations with drive-through customers, with walk-up customers. We could try to find, is adding some more grill space more beneficial? Is adding fryer space more beneficial? A lot of different ways you could take a model like this. But really the main takeaway is the structure of just how we can establish that hierarchy with data in hand, and how we can analyze the different KPIs and efficiencies that come with that. So this is just an example of how you could start to take your model and where you could go with it. But just gives you a nice idea of where models can go in this given space. So I'll pause for any questions at this time. Otherwise, we'll get into some more concepts in a slightly different model.
So there are some questions, Drew, but I'd suggest let's hold these till the end. Keep rolling, and we'll go to the questions.
Very good. And I'll cancel this just for time's sake. There's other supplemental material we could talk on experimentation at more length, but just showing the exercise that could be performed. So let's cancel that. And in this case, that hierarchy that exists and those matching of members and parents is key in this given model, because ultimately we're cooking to order. So the kitchen, it responds to orders that come in from the customer. So we're matching a particular item back to a particular order that it came from. But in other systems, maybe we're making to stock. And as this cancels here and wraps up, we'll get to that. So in a moment's time, and I've run a lot of concurrent scenarios, but yes. So in a cooking to order scenario, and let's make sure that experiment closes out, run a lot of concurrent things. So the cores on my machine were pretty heavily used there. But in these systems, and I'm gonna, again, as a Pittsburgh-based company, and being in the heart of baseball season, there's my beloved Pittsburgh Pirates. Every so often, they have what they call $1 hot dog night. And this generates a lot of interest among fans in the Pittsburgh area. So naturally, a $1 hot dog night leads to long lines at the concession stands. And so therefore, the concession attendees need to make sure that they have hot dog inventory sufficiently maintained. So they're going to cook in this scenario previously, where we were waiting for orders to come in order to generate orders, or in order to generate cooking. In this case, the cooking, we're assuming that the demand is going to be there. We're just going to cook to stock and try to keep up with the demand. So in that, how that ties to the batching, we'll touch on some of the slight nuances in system setup. So if I just run this model for a little bit, we'll start to go through some different concepts. So in this case, on any given night, the popular item on $1 hot dog night is going to be obviously hot dogs. But in these cases, there are also some instances where they offer a few other non-promotional items. And this being, there's the occasional burger that gets ordered with a given customer order. So we've assumed in this case that in the back of the kitchen, we're just going to have burgers be cooked with a random arrival rate. So every 3 minutes, we're going to make sure a burger's cooked, and every 0.25 minutes, we're gonna add a hot dog into the system, and we're going to be cooking those. But in this case, maybe typically you could think about if we wanted to cook in a batch, you could go down the route of using a combiner. But there are instances where maybe it's advantageous to use, maybe you don't want to batch, or maybe when you really want to have single piece flow, there are instances where maybe you want to have an extension of batching behavior while maintaining a server object. So in this case, this grill is a server, but it's going to have batching-like behavior. So when we have our item arrive and our entity arrives, we have a process that on a server, we're going to designate a little bit of logic. So we're going to look on initialization, we're going to see, do we have 8 items in our queue, and are we idle actively? So, we'll run this just to show this in a little bit of length. So we have our hot dogs coming in to arrive, and instead of cooking them one by one, we want to wait till we have a full pack ready to be cooked. So when they arrive, we're going to check to see, is our allocation queue enough to be considered a full batch? If it is, we will let this pass through. Otherwise, we're going to wait until this monitoring event takes place. And this monitoring event is going to ultimately check to see, is our queue greater than 8? And once we see that our we see that our server queue is beyond the range that we're seeking, we will then allocate the server to take all of the queue members at one time, and they will be processed simultaneously. So in this case, when we get all 8, in this case, hot dogs onto the grill, we're going to process them with a fixed value of our uniform distribution multiplied by the number of capacity units allocated. So in this case, if we're cooking 8 hot dogs at one time, it's going to be a random uniform sampling multiplied by the number of hot dogs on the grill. And we're doing so just so that when we make these batches, we're going to then funnel these ultimately to our tray preparation. In a point where instead of matching members to a given parent, matching members to a unique order that it was called upon, these trays are just going to be what moves us from our kitchen in the back to the concession stand. So at this given, and this is again a combiner here, at this given combiner, the tray itself is just going to be what delivers the goods to the given station. So we want to distinguish on each tray, only match the members with one another. We don't want to mix our burgers and hot dogs on the same tray. So our members themselves are going to see, if we're of the same entity type, we will match together. So if there will be 20 hot dogs that will be matched onto a tray, and then we'll wait for 20 burgers to be matched onto a separate tray. We don't want to have those be matched together. So that's kind of, we see here that as our hot dogs are cooked, we're batching burgers onto one tray, and then eventually once these have finished process, our food runner will take them over here, and we'll set up a separate tray with our items. So we count our items on our tray, and we're going to wait until there are 20 items, at which time we will send them to the concession stand to be used. But then there's another caveat to that, in that, especially in the food and beverage space, timeliness is important. We want to make sure our products are fresh. We want to make sure that we don't have anything spoil. So that there's also the notion of a release batch early trigger that is in place. That is checking to see that is on that tray of food, if the tray has been waiting for 8, and that's 8 hours is a lot of time, but if it's been waiting for 8 minutes or more, we're just going to take the tray over to the concession stand prematurely. So if we're waiting for 20 batch members, but if we don't have 20 after 8 minutes, we're going to take what we have and bring it over, because that's what we've established as period of expiration for what we can allow to be waiting with our food. So when we see our trays get assembled, our items will be cooked with varying rates again. So we're cooking one burger at a time. We're cooking a batch of hot dogs. And as they're cooked, we see our line is being assembled, waiting for their order fulfillment. And we'll take a look at the order fulfillment over here. So we'll get our hot dogs, and I'll turn up the speed here. So we get our trays, and we start to see the movement of our restocking and making sure that we have adequate inventory in our system. At this order fulfillment station, this is where we need to have matching members and parents. So because we have assumed that we're going to just create burgers and hot dogs just to have as inventory and have that as available entities to be consumed from, the customers specifically are generating unique orders where the customer themselves, they're going to say, in my given order, I need, and this is the maximum quantity on $1 hot dog night is you can have 4 hot dogs at one time. So as is tradition, you would get 4 hot dogs in your order. And then there's also a chance that you would order a burger as well. So this is where we can say that we need to uniquely have, in order for this customer's order to be fulfilled, they need to have 4 of those hot dogs in the member inputs to be used in 1 burger as well. So that's where we are waiting for those particular quantities to become available. Upon doing so, we will fulfill those orders and the customers are able to go back to their seat. But we see that this queue is being built up here because we don't have sufficient quantities of hot dogs readily available for the users. So we are waiting for that tray to be refulfilled and resent back to the given station. On doing so, we see that the customers get their orders filled. So that's an important piece to note, is that parents, really it is cognizant, or it is considerate of knowing what the order ID needs and matching the order itself with specific members. Whereas an order can have identifiers, whereas these trays are just going to be recycled through the system, and they don't really have a preference for what they carry. They just need to make sure that what they carry is of the same type. So another point to note there. But a few different ways we can visualize the systems, and certainly this is probably some rather unique instances of how we enact batching behavior in our given models, but hopefully there's a lot of parallels that can be drawn from this today to the industries in which you work. But one other point to note before we conclude, also, if you're thinking about different symbits and different resources available, plenty of other symbits to consider related to batching logic, different things related to combiners and separators. So a lot of other content at your disposal for consideration. But with that, thank you all for joining, and I will open it up to questions.
Good stuff, Drew. Thank you. A good presentation. I think the first question, the most important question that came in was, on a $1 dog night, how many are the most that you've eaten? I don't know if you want to answer that question or if you want to plead the fifth and say, let's move on to the actual technical questions.
Well, I won't get too much into the baseball jargon, but when you get swept up with the Pirates ambiance, it's hard not to do one hot dog per inning, but that usually is when the moon and sun are in alignment.
Okay, all right. So hopefully your Simio model has enough hot dogs you don't have to wait in line each inning.
Yeah, I wouldn't model myself as a member of that queue because I would probably skew the end statistics as far as batch quantity.
All right, good stuff. All right, in all seriousness, so a couple questions came in. I know we have a couple minutes left, so let me get to these questions and then we will wrap. First question, if you have 2 parts that should be grouped together, how do you know which should be the parent?
Yeah, and I think that goes back to the original slide in that you want to understand what are the points of focus in your given model. So using the analogy of a pallet and boxes on a pallet, if your point of study is order fulfillment and getting pallets onto a truck, the pallet would be a great candidate for your parent because that is the general point of study. If it's something where maybe you have 2 components being assembled into one, and then those are a greater part of another assembly, really you could think about a few different ways there. It's really going to be the parent with its batch members. The parent is in the Gantt and your different reporting, the parent is going to be what is more readily reported, and your batch members become more of a sit on the parent. So whatever you want to have more statistics gathered to, generally that would be that would be my first indicator for which would be the parents. But certainly there's some nuance to that, and it is discretionary case by case.
Okay. All right. Good. Good. Going back to your drive-through example, with your car, did you need to batch the people into the car first so that you could unbatch them at the parking spot, or can you unbatch entities that haven't gone through batching logic?
Yeah, and I think that's a great point. In that given example, I made the assumption that I will not have customers first batched. Customers in this case are generated from the state variable that I've assigned. So customers are generated using a state variable. I could certainly have this be extrapolated out, and I could have customers batch at a remote location as they get into their car to go to the restaurant. In this case, I've made the assumption that this will be sufficient for my modeling goals, to have a state that is representative of those customers. And I only want to have them be considered once they're in the confines of the restaurant space. And again, it goes to the approach of what you want to visualize, to what extent, and what's most important for your model.
Okay. All right. Good. Good. Let's try to get to 2 more questions here before we wrap. You have a lot of combiner and separator objects in your model where we typically wouldn't think of needing objects. Why did you need so many objects?
For me, I uniquely like the combiners and separators in this case, where though there may be several of them, and to mimic a parking spot, there's kind of a 2-to-1. These two are working in tandem to go to one another. But I think just because it made for out-of-the-box modeling, and I could directly just apply property values and make copies and then have the combining logic, instead of having a server where I had process logic to park the entity and do other actions in a process set of process logic, just making use of the default, it was just more beneficial to me, and making sure that it's more easily maintained to work in this space, I've found.
Okay. Okay. Good. Good. All right. Last question, and then for anyone that's still on the line here, I will bring up Drew and my email address in case your question wasn't addressed, so you can reach out to us directly. So last question, when should you use the matching rule of match members versus match members and parents?
Yeah, and I think that's one of the major points of batching logic, is understanding those instances. In a space where the parent has an order ID or some identifier that is looking for a unique set of batch members that are to go to it, that's when you would likely want to match the members and the parents. Versus in the case of if you're in a warehousing space and you have pallets that are recirculating in a given model, and they are just going to carry boxes of different types, but the pallets themselves don't really have a unique identifier saying which given pallet ID they are, that's more so when you would consider having just being match members. When your parent itself doesn't have a unique identifier to the full extent, that's generally what I would say is the case.
Okay. All right, perfect. All right, let me grab control back real quick, Drew, and I will bring up our email addresses again just for anyone that may need to reach out to us that didn't get a question answered during today's session, so you have it. So there is, once again, if it presents, there is my email address as well as Drew's. And then once again, there's also the QR code that if we are always looking for feedback, if you wouldn't mind scanning that QR code in and giving us some feedback, that would be great. Otherwise, we'll wrap there. Drew, thanks for your time today. Thanks everyone for attending. We appreciate it. And one more last alert. We are having the August session. So actually a month from today, August 18th, we will be doing what exactly is my model doing? Verification and debugging techniques. That'll be our session in August. We hope to see everyone there. Thanks again for attending, and goodbye. Thank you.